It's 7 o'clock, so we'll go ahead and get started, and I'm sure more people will be joining as we go along, but we want to welcome you to tonight's National Weather Service Boston Norton webinar. We're back after a few weeks of hiatus due to summer vacations and some active weather, but we're going to try to do these a little more regularly now through the fall. So tonight we're going to talk about Tropical Storm Isaias, which affected the area a few weeks ago. So just some reminders there on the screen before we get started. Everyone's on mute, but if you have a question during the presentation, use the chat box and enter it, and we'll answer as many questions as we can at the end. We're recording this webinar, and it'll be posted on our YouTube video page probably later tonight. And as far as upcoming webinars, we have quite a few lined up, as you can see. Next Thursday, September 10th, we have our radar and satellite interpretation course, which is pretty much a basic interpretation course, just what you can look at on radar images and satellite images to kind of identify different features. So again, it's more of an introductory course, not too technical. Then we also have a Climate 101 course, which is going to talk about some of the climate here in southern New England and a little bit about some of the climate records that we keep at the office. And then we're going to have a live demo after that. We haven't scheduled the climate one yet, but we will. But navigating our website will be coming up after that. And that's going to be a live demo kind of going through our website, showing you maybe some of the more popular things to look at, forecasts, how to find some of the climate data. And other things. Our web page, we know, has got a lot of information. It's also can be very complicated. So we want to walk you through a few things, and we'll also kind of take some live requests too to find some data that you might want to look at. So look for those coming up soon. And then during the fall, we're going to have a talk on aviation weather. It's kind of a basic weather information for those. Maybe you're a general aviation pilot or just have an interest in aviation weather. That will be good for you. We're going to begin our series on memorable southern New England storms, going from the present day all the way back to colonial times. It's kind of lined up with our This Day in Weather History on social media, but we'll go through a number of storms. And we're also going to have Winter Weather 101, which will be an introductory course to winter weather, all about nor'easters, blizzards, and that'll be followed up by Winter Weather 202, which will talk a little bit more about forecasting. So that will be a little bit later this fall. And of course, event reviews as we complete them and as we have significant weather. So as always, we really appreciate your feedback. You can email me. My email address is listed there. It's also on your webinar confirmation. We want to know what you like, what you don't like. Maybe you have an idea for a future topic. Or if you have a question that maybe we didn't get to, please feel free to email me anytime. I will get back to everybody. So with that, I'll introduce tonight's presenters. Again, my name is Joe Deli Carpini. I'm the Science and Operations Officer. My job is to manage the science program at the office, which is research and staff training, as well as these event reviews that we complete. I'm joined tonight by two of our meteorologists, Rodney Chai and Bill Leatham. They're going to walk us through this event review on Tropical Storm Isaias. So with that, I believe, Rodney, you are getting us started, so take it away.
Well, thank you, Joe. So it seems like a long time ago, but it was really just a month ago that we had Tropical Storm Isaias affect southern New England. And if you remember, it actually made landfall in North Carolina as a Category 1 hurricane. And, as with almost all tropical systems, they weaken as they come ashore, and was no different with Isaias. But there was one, I would say, factor that kind of helped Isaias sustain its strength. That was almost like a winter-like jet stream. Was very strong, over 100 knots. Halfway up the atmosphere that sustained the strength of Isaias to a certain extent. And the saving grace for southern New England is the inland track of the storm. Had it been a little bit further to the east, we would have had more impactful impacts from the tropical storm. But nonetheless, almost a million customers lost power. In the aftermath of the tropical storm, most of them in Connecticut, which were closer to the center of the system. There was also minor coastal flooding, but thankfully it did not coincide with high tide. So the effect from the coastal impacts were kind of kept to a minimum. So this is a look at the track of, what was formerly Hurricane Isaias. The yellow circles represent Category 1. You can see it made landfall in the Carolinas, and then it weakened to a tropical storm. But, as I mentioned earlier, that jet stream, which was enormously strong, really helped to sustain Isaias. But it also kind of, helped accelerate it into to our north. So the impact for southern New England was kind of limited to a 6 to 8 hour time window as the tropical storm sped away and lifted north. So let's take a look at the messaging aspect for the tropical storm. This is a graphic from the National Hurricane Center showing the wind history of the system. The lighter color, that's the tropical storm force wind, that's 39 miles per hour, sustained wind. And the brown shading, that's when it was at least hurricane force wind, that's 74 miles per hour. And you see that, as the system approached Florida, it actually weakened thanks to unfavorable wind shear aloft. And then it actually re-strengthened right before landfall in the Carolinas. So that's that kind of kept it at Category 1. So this is a graphic from the Storm Prediction Center. And the SPC, for those of you who are not familiar with SPC, they are located in Norman, Oklahoma, and they issue severe weather outlooks. And this is the day one outlook for the country. And there's actually the highest severe threat was actually in the Mid-Atlantic states. You can see that orange shading, that's enhanced risk. And most of southern New England was in a slight risk. That's kind of level 2 or 5. So that's still nothing to sniff at. And specifically, the SPC was concerned with the threat of tornadoes. As with any tropical system, they come ashore. And this would be a term that we would use a lot during this presentation. It's called wind shear. And essentially, wind shear is the change in wind direction and or speed with height. And when the tropical storm comes ashore, it can really help increase the wind profile in the environment, so that increases the threat for tornadoes. And the highest threat for tornadoes, again, is in the Mid-Atlantic states towards Pennsylvania and New Jersey. And this was one of the graphics that we put out on social media, and also that we sent out to our partners. And it's just easier to see as it shows the cities and the interstates. That's pretty much the same information from SPC, but focused more towards southern New England. And we also included an explanation of the different levels. Slight risk, again, it may sound kind of like that's kind of benign, but when we get slight risk, that's that's something to be concerned about, and kind of like a reminder to stay weather aware. And that's the graphic for day one tornado probability. That's 5%, and you see the 10% towards our southwest. And this is on the day itself. The SPC actually, they will issue mesoscale discussion, and that's that's kind of like a near-term forecast as the environment evolves, and as we get clarity on how the environment is evolving, the SPC will send out these discussions, and we will collaborate with them behind the scenes to kind of coordinate the threat headlines, like, do we issue a tornado watch? And you will see later on that we did actually for our area. And this main takeaway is that as the system comes north, there's more rotation and spin in the atmosphere, and that increases the chance for tornadoes. And this is highlighting eastern Pennsylvania and New Jersey. And that's 2 hours later, and SPC did issue a tornado watch for the Mid-Atlantic states. And 30 minutes later, 10:30 a.m. Central Time, 11:30 a.m. Our time, basically SPC is saying that they are going to issue a tornado watch for most of our area, and that's inside the hatched area because of increasingly favorable conditions for rotation. And there it is, the tornado watch until 9 p.m. On that day. And when SPC issue a tornado watch in collaboration with us, it's not just the threat for tornadoes, but there's also the threat for damaging straight line winds, in this case up to 80 miles per hour, and also the isolated hail, although that's more like a secondary threat that they this is the outlook by the Weather Prediction Center, and if you're having a hard time kind of trying to keep up with all the agencies in NOAA, I don't blame you. There are a lot of agencies, but this is the Weather Prediction Center that they're based in Silver Springs, Maryland. And what this is trying to say is that the biggest flood threat is really towards the west of our area, kind of more towards where the center of the storm is. And earlier we show you that the track of Isaias is pretty much inland, kind of up the Hudson Valley. So most of us, we were kind of in a marginal threat for flash flooding. And what helped, I would say, reduce the threat of flash flooding was how dry we have been prior to the storm. And, you will really need a lot of rain in a short period of time to cause flash flooding, other than those nuisance flash flooding in urban poor drainage areas. But then again, the threat of flash flooding is minimal. And this is one of the infographics we sent out to the partners, and that we also shared with you on social media. On the left-hand side, you see the image of the track from National Hurricane Center, pretty much an inland track. And on the right-hand side, we try to highlight the important information that's actionable, and what are some of the things that can affect people, and mainly the strong winds, and that can lead to power outages, and the threat for a few tornadoes across southern New England. And if you live near the coast, you have to be aware of minor coastal flooding, especially if you live in a south-facing beach area. So let's take a look at the models. So the models, they did pretty well in highlighting the wind threat, and this is looking at the European ensemble. A quick note on why we look at ensemble instead of what we call deterministic forecast is, models like the European model, they actually comprise of multiple members, and as forecasters, we get more confidence when most of the members show a similar outcome or solution instead of just one random member. So if the ensemble is showing that, there could be 60 mile per hour gust, over a wide area, that gives us more confidence that, at least parts of our area can see damaging winds. So in this case, the wind threat was focused more towards the western zones. And this is also from the European ensemble. This is the probability of the wind gusts exceeding 50 knots. That's severe criteria. And you can see pretty much of the area has almost close to 100% chance of seeing 50 knot wind gusts. So that is pretty high confidence. And this is looking at probability of wind gusts exceeding 64 knots. It is concerning that, there is at least, like 30 to 50% chance of seeing that kind of wind gust. So especially towards the western zone. So we did try to, emphasize in our messaging that some areas could see very damaging wind gusts. And this is taking a look at the high-res model, the HER. This is the significant tornado parameter. And you can see that there are some very high values towards New Jersey and New York City. And sure enough, that was where SPC had a 10% probability of tornadoes. But for us, it cannot, the tornado threat is non-zero. And there are some elevated values as well. And it really is not that important to focus on where that local maximum value is, but this is just to show that the threat is there for the entire area. All right, taking a look at the meso analysis. And as I've mentioned earlier, the jet stream, and this is looking at way high up in the atmosphere. There's some very strong winds above 120 miles per hour. And when you have that kind of wind profile, and which is very anomalous for summer, it's almost like a winter-like system. It really helped to, one, it helps to sustain the tropical system, and two, if you can bring down some of these winds, it can really cause some damage. This is taking a look at the surface pressure map, overlaid with the surface wind, and you can see that's the center of low pressure for the tropical storm as it lifted up the mid-Atlantic states. And those bright shadings, that's radar, and that's the brighter shading, that's heavy rain. And you can see much of the heavy rain is to our west. But so for us, it was Isaias was really more of a wind threat than a rain threat.
And Rodney, I'll just add on this. Notice it's still a tropical storm, but we don't have that nice circular pattern on the radar anymore. And this is pretty typical of tropical storms that are heading up into the northeast. It's that jet stream that Rodney showed up here is providing so much lift. It's actually focusing the heavy rain to the north side of the tropical storm. So this is a pretty typical situation. What you'll see, you'll lose that nice circular appearance on radar, and everything will be kind of on the front end of the storm. So again, pretty typical situation as these storms head north. They almost become like typical nor'easters, usually as they reach New England. So a pretty typical thing, Rodney.
Thank you, Joe. And this is, another map showing the surface observations. It's kind of hard to see, but if you go on to the next slide, zoom in a little bit. The black value, that's temperature. The blue is dew point, and the red values are the wind gusts. And you can see some stronger wind gusts as the storm lifted north towards the mid-Atlantic states. And And unsurprisingly, the dew points were in the low to mid 70s. That's the kind of tropical air mass you get when a tropical storm heads our way. This is what we call precipitable water, or we call PWATS. Pretty much that's, if you take all the moisture in the atmosphere and kind of, you rain itself out, that's how much rain you can get. And of course, you don't get all the rain or moisture from the atmosphere, but it kind of shows you how moist the atmosphere is. And there are some values above 2 inches towards the mid-Atlantic states. And unsurprisingly, the areas with the higher PWATS receive more rain out of this. And this is taking a look at the instability, or what we call surface-based CAPE. And essentially what this means is that we want to see how much lift there is in the atmosphere. And sometimes you may hear that, like on cloudy days, like people would say the atmosphere is capped. And what this means is that the air parcel is not being able to lift into the, from the ground, because you don't get that temperature gradient. Because remember, warm air rises, so you need the surface to be warmer than what it is above it. So in this case, the higher values correspond to more favorable conditions for lifting, and that typically happens with when there's a break in the clouds, when there's sunshine, and that allows the surface to be heated up. So it is concerning that there is actually up to like 2,000 joules of CAPE, and that's but that's just only one part of the equation. And let's take a look at some other aspects. And this is the 0 to 1 kilometer storm relative helicity. Remember how I mentioned the spin in the atmosphere, and the one main reason why there's an elevated tornado threat is because there is rotation with height, and once you get above values like 100, you will catch our attention as forecasters in southern New England. And in this case, the storm relative helicity is off the charts. You're seeing values above 500 towards the mid-Atlantic states, and that's a very favorable environment for tornadoes if you can get the parcels to be lifted. And this is what another thing we look at is called the Craven-Brooks Index. And what this index essentially is it is a product of instability and wind shear. So, and when we see values above, and these are in 10,000, so when we see values above 20,000, that again catches our attention. And on this day, the values are as high as 40,000. So there was a very significant threat for severe weather if conditions are right. And this is the significant tornado parameter. And unsurprisingly, the higher values are towards the mid-Atlantic states, where they had a 10% probability of tornadoes. But for us, you can see that's there's also a positive value as well. So the threat for tornadoes is non-zero. And this is just another way to look at the probability of tornadoes. This is essentially the probability of seeing EF0 tornadoes, which is the lowest level on the tornado scale. And you can see there's a wide swath of 15 to 20% across our area. So pretty abnormal day And this is EF2, and that's you're really talking about significant tornado. Again, it is the probability is lower but non-zero. So right now, I'm just going to pass it on to Bill, who's going to talk about what happened that day.
All right, thank you, Rodney. So we already kind of showed this image here, but the big thing that we could see is that the hurricane it went up into the Carolinas as a Category 1 storm, and once it made landfall, it lost one of the important ingredients that it needs to keep itself as like a tropical system, and that's it's the warm ocean water. And as you can see, it moved up into our neck of the woods as a tropical storm. Now here is just a regional radar loop showing kind of what Rodney was looking at earlier on the SPC meso analysis page, but you know, going through over time. And as you can see, all the heaviest rain falling up along the mid-Atlantic and into the Hudson Valley and into New York. And for us in southern New England here, we just had that one line of showers and some embedded thunderstorms that slid through, and that's what helped bring us some of those strong wind gusts that we got throughout the day. Now, just taking a look a little further down the coast, this is in the Delmarva Peninsula area. You could see some of those strong wind gusts that occurred from the system. There's anywhere from 50 to 70 plus mile per hour winds in that area, and that's what was heading up our way. And if you go to the next slide, this is looking a little closer to our area. Now, this is the maximum wind gusts since midnight of that day. And this is right around 2:30 p.m. And as you can see, even across New York, we still had some 50 to even some low 70 mile per hour wind gusts in the New York area, and also getting into Connecticut. And then I think, as we kind of talked about it earlier, with these kind of systems, usually what happens when it gets up this way is that the heaviest rainfall tends to fall on the western side of where the center of the storm tracks, and then usually the eastern side of the storm is where we get all the strongest winds. And as you can see in this image here, I mean, most of southern New England didn't really get that much in the way of rainfall. However, if you look across into the mid-Atlantic up into New York, there was anywhere from 3 to even some spots which got up to 6 to 8 inches of rainfall, especially close to the Philadelphia metro area. And then this is just zooming in on that same image, looking specifically at southern New England. Again, we really didn't get much needed rainfall at the time. You know, anywhere from a couple hundredths to a tenth of an inch with those showers and storms that were moving through. But again, just to our west, you could see that there's anywhere from 3 to even some 5-6 inch rainfall amounts. So that's one of the big things, that when we're looking at these systems several days out, any sort of small shift in the track can shift where that heaviest rainfall or where the strongest winds can occur when they get up this way. So that's one thing, you know, to pay attention to when we have looking at these storms several days out. And then this is just another image showing the rainfall observed from the radar down in the mid-Atlantic, but focusing in on where the heaviest totals were in the Philadelphia metro area, where you had anywhere from 7 to 8 inches. But one real interesting thing to see here is, you know, just look at how big of a difference there is from the Philadelphia area going to Atlantic City. Just a small shift in the track can get you only a quarter inch of rainfall, and then up to the, you know, Philadelphia area, you got 7 to 8 inches of rain. So that the track of that center of that system is a big factor in where it gets the heaviest rain and where you don't get that much. And one other thing that we were concerned about, but is a tricky thing with these kind of systems, is storm surge. Now, what ended up happening is the storm, we did end up getting, we did end up getting some storm surge from the system, where there was anywhere from it was around 3 feet, 3 feet of storm surge. But what's tricky up in our neck of the woods is that the winds have to coincide not only with the storm surge, but also with the tide. So if this occurred a little bit later, then we would have seen more flooding impacts from storm surge from the system. So because it moved in a little bit quicker, which is actually typically what the storms kind of do, we didn't get that much storm surge from the system. And then this is just a look at, as folks are probably aware of, there's widespread power outages across Connecticut. And one interesting thing that it might be tough to see in this image, but we also had some, with those strongest winds on the eastern side of the system, there was probably a little bit of funneling that went on right up the Connecticut River Valley. So that's why you see, at least in this image, there's some higher concentrations of power outages in that area. And again, I mean, people were out of power for several days. And then this is just a look at the power outage map across Massachusetts. Again, with most of the highest amount of outages pretty much located across central and into portions of western Massachusetts, but there were some outages across the east as well. So as Rodney kind of alluded to earlier when we were looking at the meso analysis, which is basically just looking as a different, we're just looking at the weather in a different scale, and Joe will probably we'll talk a little more about it later. But so the way it would happen ahead of the storm, we had some showers in the morning, but those showers cleared and we were able to get some sunshine, which helped us get that instability, which brings a greater risk for stronger thunderstorms, because that's one of the ingredients that you need for stronger thunderstorms is instability. And we also had a lot of spin, or what Rodney had showed was like the helicity. We had a lot of spin in the atmosphere. And so early and mid-afternoon and even into the final band of showers coming in, there were threats of tornadoes. And I mean, we have a list there of 5 tornado warnings and 4 special marine warnings, which was probably for the water spout risk. So if you keep going, we've got more. Now, the one thing that's tricky with these kind of systems is these tornadoes can form very quickly, and it's not as clear cut as, say, the storms you would look at when we're looking at like the Central Plains. So you could see on those warnings that we had there that there was a little bit of rotation on those systems and on those particular storm cells. So unfortunately, they're very quick, and at least in this instance, we didn't have any reports of any tornadoes across southern New England, except for I think there was one in southern Connecticut. But we'll get to that a little later. I want to keep going, and then this is just another loop showing if you can see the teal colors, those are special marine warnings. The red are the tornado warnings, and then you see those little hurricane icons. Those are just reports of wind damage from the tropical system. But you can see here that there's several different tornado warnings or special marine warnings, and the main risk that we put out for those were the red ones are for tornadoes, and with the special marine warnings, it's primarily for water spouts. And then this is just a loop once that line of showers was getting further east into eastern Mass, and then also up into Cape Cod and into the islands. But again, you can see those special marine warnings, and there's that one tornado warning up by the Fitchburg area. Now, one thing that also that kind of strikes us is we usually see what's going on downstream or what's going on behind us, or when the storms are coming into our area. And as you can see here across the mid-Atlantic and into parts of the southeast, there were several tornado reports on the 3rd on top of wind gusts. And this is this is with the storm coming up our way. So that's also one of the things that kind of perks our ears. Like, okay, there's been tornadoes that have happened with this system. It's not out of the question that it happens when it gets up here, because it happens, further away from us. And then if you keep going, and now this is just a storm reports across our area. Now, I did say that we didn't have any reports specifically in the area that we forecast for, but there was that one tornado report that was found in far southwest Connecticut. Now, it's not out of the question that there could have been some tornadoes in our area, but we didn't receive any damage reports that kind of showed it. And it's also kind of tricky when you have such strong winds going through this, because when you have 60, 70 mile an hour winds, or even a little bit lower, you could still get significant damage that looks like a tornado went through the area. And then this is, I probably won't talk too much about all these, but this is just several different pictures and some videos of the various damage that, a lot of folks probably have maybe seen, but you'll see here just lots of trees down. This is on I-84, and then right here's a part of a roof that was blown off in Connecticut. Another tree knocked down, and again, and this is in West Hartford, and then this is another angle of that building that had the roof blown off in Wethersfield. Again, some more trees down, also some power lines knocked down, probably due to those trees falling on the lines and bringing them down. Some more tree damage. A tree uprooted and knocked into a home in Springfield. Some more, yep. Lots of tree damage, and even this is getting out into Eastern Mass. That was where, in the Norton area. And then this is in Cumberland, Rhode Island, where there was also tree damage. So lots of tree damage from this system, and it was only a tropical storm, which makes you worry when, if this is only a tropical storm and this is the kind of tree damage that we get, what would happen if we get a hurricane or even a stronger hurricane that goes through. And then this is just an image from our Twitter, just showing that once the storm had come to an end, we posted that we got rid of all of the tropical storm warnings and anything associated with the storm. So to kind of summarize here, the system had impacts that were consistent with a tropical storm that tracked west of the region, which if folks remember Irene, it was kind of similar to Irene in the sense that on the western side of the storm, there was heavy rainfall, whereas on the east, there was a lot more winds, and also there is the potential usually for tornadoes on the right side of the track. Now, again, we didn't observe any in our neck of the woods, and that might be because maybe we're a little bit too far removed from the center of the storm, but there's still always that risk with these kind of systems. And one other thing with these kind of storms, the reason that we get, or the reason that we think that we get so much tree damage is that the winds turn out of the south or southeast, and the trees in southern New England aren't really hardened. We don't typically see winds out of that direction, so they're really not used to getting strong wind gusts. So that's why the healthier trees break, whereas they're typically kind of used to stronger winds out of the west or northwest or even the north and northeast, which are a lot more common. So that's why we see such widespread tree damage with these kind of systems, is because once those winds turn out of that kind of direction, it causes a lot of havoc with those trees, because they're not used to that kind of direction. And then, this is probably a good time too to not only thank the Skywarn observers and also you folks out there who have given us information as the storm is going through. It's really, really helpful, and it helps us see what's going on the ground. So thank you.
All right. So with that, Bill and Rodney, thank you very much. Great presentation. So with that, we'll go ahead and answer some questions here. So let's see, Rodney and Bill, I'll let you handle most of them if you like. So first question from John: where would tornadoes be located? The rear flank of rain bands. Bill, do you want to grab that one, or you need me to help?
I mean, honestly, any of these, I would say with any of these storms that pop up, you can really get, if you get any sort of rotation in any of these showers or even a thunderstorm, some of these don't even have thunder with them. So you can actually get it with pretty much any of those little showers that are going through. It's just keeping an eye on the rotation that on the radar.
Right. And John, these storms are not like our typical summertime storms where we would have, a really well-defined storm. These can be just very, very quick spin-ups that maybe last a minute or two. So usually just look for those yellows and particularly orange or even a little bit of red on the radar there. That's where they probably would be located. But they're moving so fast, probably 50, 60 miles per hour. They're not going to last very long at all. So good question. From Jane, are the SPC discussions and information on storms available to the public in real time? I guess I can answer that. Yes, they are, Jane. If you go to spc.noaa.gov on the web, all of that information is there. You can find that. It's also on social media. You can follow SPC on Twitter, or a lot of times we'll retweet those discussions from them as well. But again, it's spc.noaa.gov. And if you want more information on SPC, you can go onto our YouTube page. We have our Severe Weather 202 course, which is on forecasting, and that goes through a lot of what the SPC does. So good question. Okay, from Donald, you said that as the storm moves north, there is a change in wind shear. I don't understand. So I think, Rodney, that's when you were showing the area on the meso-analysis of strongest wind shear. So Donald, I think he was referring to that area of wind shear lifting north as the storm moves north and strengthens. So again, wind shear is a change in either wind direction with height or wind speed with height. And with a tropical storm like this, usually very close to the center, just to kind of the north and east of the center is where your strongest wind shear can be, and that's your favorable area for tornadoes. So I think we were referring to more of the area of strong wind shear increasing as the storm moved north. So I hope that answers your question. From Samuel, is there typically hail with tropical systems like this? Isn't hail with cold weather systems not warm? All right, boys, who wants that? Let you win.
I can take it.
Okay.
So typically in a system like this, because it is so warm, the hail is typically not a concern, although it can occur as well. Especially if the air aloft is colder, because you do need the hail to survive the fall to the ground. But in this case, it's such a warm system. Unless it is very large hail to begin with, as it falls through the atmosphere, most likely you would not get severe hail out of this.
Right, and you can get small hail, certainly, but even that's pretty rare. The air is so warm all the way aloft because a tropical system is actually what's called a warm core system. It's built on kind of an engine of warm air, whereas a typical thunderstorm or even one of our winter type storms are cold core systems. So there's usually colder air aloft that helps to generate hail. So good question. We normally don't see that. Another question from Donald. What is the meaning of meso-analysis? And that's a good question, too. A little technical. So really, there's different scales of analysis that we can perform. So there's something called the synoptic scale. And when we talk about that, we're talking maybe the whole country, the United States, or something like that. Meso-analysis is a little bit smaller. Think of it as a regional analysis. So we're looking at maybe the Northeast or New England. And then we can go down in scale from that. So meso, think of it as kind of middle scale analysis. It's kind of a regional type analysis. And if you saw the maps that Rodney showed, it was kind of from the Great Lakes over to New England, so a smaller section of the country. And it's just a kind of a way to look at the environment that either a typical weather system, whether it be a hurricane or tropical storm or winter storm, or even just a severe weather day. It's a way of kind of drilling down into some of the details to kind of see how the atmosphere is behaving. Question from John. How does a fast jet stream strengthen a storm like this one? Rodney or Bill, I'll hand that to you.
Sure, Joe, I can answer that. So one way a fast jet stream can strengthen a storm like this is, it leads to deep lifting, and when you get a deep system like this, you can kind of mix the winds closer to the surface, and it's so one way to see it is it kind of when a faster jet stream kind of gives the storm more energy or juice to keep going, and typically we don't see such an impressive wind field in the summer because the temperature gradient is not as strong as in winter. So it is kind of rare to see such a strong jet stream for the tropical storm.
Yeah, and also for John and everybody else, again, when we talk about our systems, tropical systems moving north, just about all the time, there are some exceptions, but a majority of the time, they're undergoing a transition from being tropical to kind of turning into what's known as maybe an everyday nor'easter or coastal storm like we see in the winter. And it's that jet stream. It's almost if you notice, whenever we have a system coming up the coast, there's almost always that strong jet stream up over southern Ontario, the southern part of Canada. And it's that jet stream energy that helps that transition take place. So in a way, it causes those stronger winds to kind of spread out, and really the envelope of high winds around the storm expands outward, and the wind field gets greater in size, not concentrated right around the eye. So it's almost that transition that we're seeing from tropical to non-tropical, we'll call it, that causes kind of the strengthening or the stronger winds. So good question. Let's see, from Steve. Let's see. Seems like the last three damaging wind events here, the very worst gusts are right before the winds die down. Is this due to mixing in the dry slot? And he also wants us to get some anemometers at 50 feet plus in Northeast Connecticut. I would love to be able to get you some anemometers, but federal budgets being what they are, I'm guessing we can't do that. But I can answer that one, guys. So a lot of times, you'll even see this with some of our fall high wind events. You get the strongest winds occurring almost before the heavy rain arrives, and that's because the atmosphere is unstable, so it's able to mix down those higher gusts from higher up in the atmosphere. And then when the rain occurs, things stabilize. It cools the air. You're not getting as much mixing. Think on like a spring or fall day where it's a gusty day, the sun's out. You're mixing very well. If it starts to rain and we cool the temperatures down, then it's stabilizing, and the winds will die down pretty quickly. And that's kind of what happened here as well. Now, sometimes you can have it happen, as the rain is falling. If you're mixing that, the rain is helping to drag some of those strong winds down, and then as the rain exits, you get into that dry slot, and then it can stop as well. So it's kind of situation dependent, but for the most part, the strongest winds will occur just ahead of that heavy rain area, although sometimes it can mix down in that as well. Good question and good observation, Steve. From Donald, why is there increased rotation with height? Let one of you guys take that one.
Sure. So Donald, at least in this case, the reason that there was increased rotation with height is that, if you the kind of the best way to think about it in this case is winds initially at the surface are kind of light, and then with these kind of systems, usually winds are pretty strong as you're starting to go higher up, just because that's where how the storm strengthens, and it's a little higher up in the atmosphere. And so because you've got this difference in wind speed over height, that's why there's increased rotation, and that's just talking about speed. There's also, the system's also rotating itself, so that kind of adds to that component. I think that works, unless you have anything else to add, Joe.
Yeah, no, I think that's reasonable. Let's see, moving along from John, is the rotation on radar spotted by eye or an algorithm? Bill, I'll let you take that.
It's spotted by both. So we have an algorithm on our radar that we usually, and actually in these events, we set it to a lower setting to try to pick up on these storms that are rotating pretty quickly. However, we have people kind of watching it like hawks when they're working these kind of events. So that we do have them both.
Yeah, and the algorithms, think of those as like safety nets. Like if we're not aware of something, it's going to get our attention pretty quickly. But for the most part, we have in this situation, in most of our tropical situations, we have at least two people watching for rotation on the radar. So good question. From Jane, was there any flooding damage in Vermont, like with Irene? I can take that. No, there wasn't. As we saw, the heaviest rain fell out in New York, pretty much out toward the Catskills and up toward the Adirondacks. The difference between this and Irene, although there was heavy rain, was the speed of the system. Irene was quite a bit slower, believe it or not, than Isaias was. This storm, that Isaias actually was traveling a good 40 miles per hour northward, which is pretty rapid for a system like that. So the rain, we had heavy rain, not quite as much as with Irene, but it was also over a shorter period. So it was in quickly and out pretty quickly. So that limited the flood threat. And I think as Bill had mentioned too, or maybe it was Rodney, we also had very dry antecedent conditions or conditions leading up to the storm. So that helped, some of the rainfall at least was able to be absorbed, even though it was raining pretty heavily. So it really was the forward motion of the storm and the duration of the heavy rain that kept us from getting those really incredible rainfall amounts that we saw with Irene. And also it was a little bit farther to the west, so the heaviest rain likewise was also a little bit further west. Good question. Let's see. Bert has just a question. Why don't you admit you way over forecasted rain in eastern Mass? Cape Cod got 0.01. Bert, that's actually correct. What happens a lot of times is on the eastern side of these storms, we don't get a lot, little if any rain. And I think we actually had a forecast of about 1/4 of an inch, which was still well overdone. We certainly admit that. And, I can show you the forecast. We go through all of our forecasts after these events. Typically, there's a sharp cutoff in where the heavy rain is, and this time it was out near the Berkshires. As we mentioned, we know on the east side of the storm we're not going to get heavy rain. You're going to get all of your rains in bands of showers and storms, which are very localized. It's difficult, going a day or two out to actually be able to show that graphically because of the uncertainty. If this storm jogged, say, 50 miles to the east, the Cape would have had a good, 1/2 inch of rain, no problem. But it didn't, and we normally don't. Sometimes we can't see that until the storm is in radar range. 6 hours out, maybe as much as 12 hours out. So, rainfall is one of the hardest things to forecast in weather, Bert. And in the wintertime, I will tell you, snowfall is one of the hardest things to forecast. The models struggle with forecasting rainfall and again snowfall. It's the least reliable thing you will see in model output is rainfall. So we do our best, but yes, we're going to probably overestimate it a lot of times, especially in a tropical situation. I would have loved to have tell you we're not, we knew going into the storm we weren't going to see very much in eastern Mass and on the Cape. We were saying it's going to be less than 1/4 inch. And that turned out to be the case. 0.01 to 1/10, that's tough. That's a gutsy call with a tropical system. Even when we know it's well east of the center. So, like I said, we do the best we can. We do review all of our forecasts, whether they're from a tropical system or not. And I can tell you, as the one who manages the Office of Science program, I train these guys hard every year, whether it be tropical weather, winter weather, or just typical rainfall forecasts. So Bill and Rodney can probably tell you how much the training I give them. But we do our best. It's not a perfect science, and we learn and hopefully move on and do better next time. So I know a lot of people on the Cape, especially, were very disappointed with the rainfall that resulted. But that sometimes happens. So we do the best we can. From D, for our area of southern New England, when are we most at risk for severe hurricanes? Rodney, I'm going to give you that one.
Sure. Yeah, it really depends on the track of the tropical system. And in this case, for Isaias, that it made landfall in the Carolinas, and then it subsequently took on a more northerly track. It lost that connection with the warm ocean waters, which is probably the single most important conditioned to sustain hurricanes and tropical systems. So for us to be hit with a hurricane, never mind, a severe hurricane, and that would be like Category 2 or above, it would have to be kind of stay over the waters, and would have to, and assuming the ocean water is warm, a lot of times when the ocean waters off southern New England, there's a very sharp cutoff in the warm sea surface temperature, like 80 degrees and 60 degrees just in the Gulf of Maine. So the odds are, it's stacked against a landfalling hurricane for southern New England, but it could happen, and it has happened before, like Hurricane Bob, but it would have to really kind of almost like hug the coast at the east of the eastern seaboard and made landfall like probably along the south coast, for us to see a high-end hurricane.
Right, and Dee, if you're talking about the season, pretty much now September is the peak, kind of the middle of September especially. But I would say anytime in the hurricane season, June 1 to November 1, but especially as we get into later August and especially September, that's when our main window for the stronger hurricanes is, just because the water is so warm. And the one rule of thumb we like to tell people is, yeah, you can watch the storms coming off Africa. There's a couple, if you're looking now, there's a couple of disturbances out there that could form into tropical storms, but really watch, anything in the Bahamas. So we always say anything in the Bahamas with a name is really our business, because those are the storms that historically tend to come up the coast and can come up here quite quickly as they accelerate. So that's a good question. But now we are right in prime time for hurricane season. Question, I'm going to give this one to Bill from Ethan. Would tornadoes from rain bands and tropical storms be considered landspouts, since the showers wouldn't be supercellular? What do you think, Bill?
Ooh, that's a more complicated one.
Yeah. Well, I would say they're not typically those bands they do contain what are called supercells, the type of storms that produce tornadoes. They're low topped, or we call almost a mini supercell. Yeah, a landspout is a little bit of a different beast. But that's a good question, Ethan. I definitely would probably lean toward the side of like a mini supercell, just from the structures I've seen, when working radar. It's just on a much smaller scale than, say, like a June 1st, 2011 supercell that produced a long track tornado. Good question. I think you stumped Bill. Okay. From Joe, where were the forecasters at Norton using the MJO phases to help forecast the track? I can take that one. Typically, no. What we do is the tracks are coordinated with the National Hurricane Center. So what we do is when we're under anywhere within that cone figure, the 5-day cone, we're coordinating with the National Hurricane Center on conference calls. These days, it's video conference calls, because most of us are not physically in the office days ahead of time. But the MJO is used more to kind of show, develop the pattern. That's a little more technical that some folks may not understand, but that may help, understand the general weather pattern around the United States or even off the East Coast. But typically, when we're looking at forecasting the track of a storm, we're relying on that model guidance, and we're certainly relying on the National Hurricane Center and coordinating that with them. So, good question. Okay, from Michael. Let's see. Here in Farmington, Connecticut, the strongest winds did occur along the line of showers that passed through the area. The interesting observation was that these winds continued after the line of showers passed. What was driving those upper level winds down to the ground after the line of showers had passed? I can answer that, guys. So again, a tropical system. It was warm. If you remember, after the storm departed, even the next day, it was still pretty warm outside and kind of tropical feeling. Not like when we get a typical coastal storm comes by and it gets cold behind it. So the air was still able to mix, like I talked about before. It was warm and it was still unstable, and the upper level winds were still strong as a result of that upper level jet stream, which was up over Canada, combined with the remnants of the storm. So the wind field was pretty expansive, covering a lot of the Northeast at one time. And it was just that leftover warm tropical type air that allowed things to keep mixing. Although the strongest winds, as you mentioned, were in the showers, that helps bring down, those strong winds. The gusty winds continued for several hours afterwards as well, just because it was just such a warm air mass and we had that leftover instability. So good observation and good question. Let's see, from Robert, how well do groups like Eversource get briefed on winds and other storm threats? Seems to me in Connecticut, Eversource had been out trimming trees for most of the summer. I guess I can take that, guys. We do. They do receive weather briefings. A lot of the power companies have private meteorologists that brief them, but they also take part in our conference calls, which we provide to the states, Connecticut, Massachusetts, and Rhode Island. So they are briefed from us and from their own particular weather source. And yeah, there is a lot of tree trimming because you have to, make sure none of them are getting near the lines and whatnot to cause power outages. So yeah, most of the power companies do receive weather briefings both from us and from their own companies. So good question. I'm sure many folks did not know that. Let's see. Question from Jane. What is the difference between a tropical system and nor'easter? I probably answered that. Think tropical system as warm core, meaning warm air is kind of wrapped around the center, and a nor'easter is a cold core system. So there's it's colder air and kind of temperature differences that drive the strength of the storm. So kind of think opposites in a way. But again, as our tropical systems come up here, they start to transition at least most of the time into what we would call a nor'easter. Sometimes that doesn't happen. Hurricane of 38 was probably a good example of that. Let's see. Question from Vera. Did the drought have any effect on storm damage? Ooh, that's a good question. Hey, Bill, why don't you take that one?
Sure. I would say it definitely did because I would say with respect to the trees, it probably weakened the trees in the area just because of the lack of rainfall. And that helped with those strong winds, help bring the trees down probably a little bit easier, especially for some of the healthier trees. But it probably also created, enough diseased trees where they've got knocked down as well. So, yeah, I'd say it did.
Yep, I would agree with you. Good question, Vera. That's a good way of looking at it. Thinking of potential storm damage, even for us ahead of the storm. That was one of the things we were considering. From Robert, this is kind of an office question. How many extra hours did the team have to work for this event? And thanks for doing so. Well, thank you, Robert. So typically when we're under a direct, say, a situation like this where we know it's a landfalling tropical system, we pretty much go to 12-hour shifts with two teams. So one team will kind of work 7:30 in the morning to 7:30 in the evening, and then our night crew will go 7:30 in the evening to 7:30 in the morning. And that's what we did in this case for, I think, a couple of the days, if I remember. Sometimes the forecast staff typically works a 9-hour shift. Sometimes we'll extend those to 12 hours as needed. But as far as extra hours, it depends. We called some people in who are on days off and they worked a lot of hours. I'm trying to remember who we called in, but we typically will have on each shift. Bill and Rodney, you can help me with this. I think I was working the night shift with that crew. I think we had 5 on for one of the nights. The day crew, I think, was either 6 or 7, maybe. It's a little busier.
Yeah, maybe 8.
Yeah, because we have more of a phone load, obviously, during the day and more briefings to emergency managers to handle. So that's why I like the nights. It's usually a little quieter, even though you're up all night. So that's typically what we do for a landfalling, system. We did that for Irene as well. If it's an offshore system, we typically will stick with our 9-hour shifts and maybe just have people stick around a couple of hours if need be. But that's a good answer, a good question. And we also do that. The 12-hour shifts are kind of all hands on deck, so we do that for the big blizzards also, big nor'easters, any event where we've got really a pretty high workload. So good question. Let's see. Steve has another question. Have you done any assessment of salt damage to vegetation on the South Coast, like the New York office did? I don't believe so. Bill or Rodney, I don't know if you're aware of that. I don't think we had the extent of, well, first, the extent of the winds. I know there were the winds on the south shore of Long Island and Connecticut coast were much far stronger. But I haven't seen, that wouldn't be necessarily something we would do, but we would work with other agencies on that. But I'm not aware of anything. Are you guys, Bill or Rodney?
No.
No, Joe.
Yeah, I'm not sure, Steve. Steve, you can always shoot me an email, and I can find out for you. Let's see. Oh, let's see. Fred has a question. We are way overdue for a large hurricane in southern New England. Fred, wiser words could not be stated. As Rodney said, Hurricane Bob was the last landfalling hurricane. That was, for those of you who remember, it was a Category 1. That was back in 1991. And prior, you have to go back to Carroll for the last major hurricane, which was in the 50s. I think it was 54. So yes, we are way overdue. Our fear is that now we have a whole generation of people who live along the coast who have never experienced a hurricane. Yeah, they've experienced a couple of tropical storms here in Irene and Isaias, but we have a generation of people. We have a higher population along the coast. We have seasonal populations along the coast. So that's one of our fears, and that's why we try and give you folks, as much of a heads up as we can, as best we can. It's not, certainly, like I said, not an exact science, but at least, we want you to be prepared. And, this is the time of year we want you to be watching the tropics. Go to the National Hurricane website. Again, anything in the Bahamas with a name, that's our business. But certainly be prepared, and also have a safety plan. If you go on our website, up at the top, there's safety information. Go to the hurricane page. Get prepared for the season. It's not too late. Not just if you live along the coast. If you live inland, flooding is the big threat for you. Also, inland tornadoes can be a threat. So, never too early to be prepared. Good point, Fred. Thank you. Another from Jane. How is climate change affecting the risk for tropical storms in New England? You guys want me to handle that one?
You can if you want. I mean, it kind of breaks down to, I mean, with the warmer ocean, which is one of the things that feeds these kind of systems. It's going to increase the risk, but it's a real complicated system. There's other things that could happen, but just focusing on the warmer ocean temperatures, that would increase the risk for more tropical systems.
Right.
And also the other thing is, a warmer atmosphere can also hold more moisture and water vapor. So areas that get rain, they will get heavier rain. And so that could lead, especially when the system is slower, and it can really produce life-threatening rainfall over a short period of time.
All right. And I should mention, Bill manages our climate program, so he's a good source for that. Let's see, from John. Oh, there's a comment. What I learned, the National Weather Service needs more FTEs, or full-time employees. Well, John, I'll tell you what. Actually, the way things are going now, the National Weather Service has hired a lot of new people. You've probably seen or heard of some of the folks here are fairly new. Hiring has been actually pretty good. Congress has helped us out quite a bit. Our office is now fully staffed, believe it or not. So we're doing pretty well, and other offices are doing well as also. So, but thank you. Bert mentioned the Cape had no salt damage like in Bob. So at least for Cape Cod, there was no salt damage. But I can certainly find out more information. Fred mentions Gloria was bad too in 1985. That is correct. But I believe, I was in New York City at that time too, and I remember Gloria. Bert mentions Buzzard Bay reached 80 degrees 10 days ago. Oh, I don't want to hear that. That's one of our rules with the water temperature. 80 degrees or higher is good, favorable for hurricanes. This is the time we're getting to our peak water temperatures here in New England as well. So the warmer the water, the more energy potentially we have for tropical storms. So that will do it for our questions. So a lot of good questions tonight, folks, and thanks for hanging on. We really, really appreciate it. So from this point, I want to thank you for joining us. We have our next webinar next week. It'll be on Thursday. In the meantime, please feel free to send me some input on tonight's webinar in particular. If you think of a question, after we're done, please email me. You've got my email address on the screen or on your confirmation for the webinar. Or again, if you have any ideas for future topics, please let us know. We want to keep these going. We will continue to make as many of these available as we can. When the weather gets quiet, we have more time to concentrate on these. But folks like Bill and Rodney in particular, they're working shifts 24/7. So these are the folks that help me bring these to you. So again, I want to thank you for joining us. It was a great presentation tonight and a lot of really good questions. I appreciate everybody's attention, and we will see you next time. If you missed a section of this or want to go back, this will be posted on our YouTube page probably later tonight or tomorrow. So you can always check that out. And finally, I would say check our Tropical Weather 101 webinar on the YouTube page. It gives some good basic information on tropical weather here in southern New England. That's a good kind of primer, maybe leading into this one as well. I'll give you a little more background. So thanks again for joining us. Bill and Rodney, thank you both. And we will talk to everybody next time. Have a good evening, everybody.